Let's talk indices. Maths and arithmetic are actually really old, probably one of the earliest areas of study ever since writing was invented. There's evidence that ancient Babylonians actually used complex maths. They knew geometry, they understood algebra, even advanced calculus, and they were able to use this in order to work out, well, all sorts of things. Their astronomy was so advanced that they were able to track the movement of stars and predict celestial events like solar eclipses. One thing they didn't invent, though, was indices. An index number is a number which is raised to a power. This is actually a relatively new way of showing repeated multiplication. Back in the Middle Ages, if you wanted to say 2 times 2 times 2 times 2, there was no shorthand way of writing it. You would literally have to write out 2 times 2 times 2 times 2. Sometime in the 17th century, some guy named René Descartes thought, for heaven's sakes, there are 4 2's multiplied together here. Surely there must be a quicker way of writing it. And so indices was born. Descartes was like, how about this, guys? Instead of writing out the 2 4 times, let's save paper and just write 2 to the power of 4. And everyone was like, heck yeah, this guy has the right idea. So this form of maths has continued on to today, where we have a number called the base, that's going to be multiplied a certain number of times, and a smaller number on top of it called the exponent that tells us how many times we have to multiply this number. So for example, if we wanted to show 3 times 3 times 3 times 3 times 3, well, the number being multiplied is 3, and there are 5 3's multiplied together. So we could write 3 to the power of 5, or 3 raised to the 5th power. Notice that 3 to the power of 5 is not the same as 3 times 5. 3 times 5 is 15, and 3 to the power of 5 is 243. It's a big difference. Now you might have heard the word squared or cubed when talking about indices. Usually if something is raised to the 2nd power, we say that it's squared, and if it's raised to the 3rd power, we say that the number's been cubed. So for example, we would generally say that 4 times 4 is 4 squared, and 4 times 4 times 4 is 4 cubed. There's nothing wrong with saying 4 to the power of 2 or 4 to the power of 3, it's just faster and easier to say 4 squared or 4 cubed. But why do we say this? Well, this actually links to measurement. Imagine you have a square, a literal square that's 4 units long. Let's say that each length is 4 centimeters. Well, if you wanted to calculate the area of the square, you would have to get 4 times 4. Because there are 2 4's being multiplied together, we could write this as 4 to the power of 2. In other words, to get the area of a square, you have to take one side of the square and raise it to the 2nd power. You have to square it. 4 squared is 16, so the area of our square is 16 centimeters squared. What about cubed? Well, let's say our 4 centimeter square is now a cube. Let's say we wanted to measure the volume of this cube. Let's say we wanted to fill it up with something and we wanted to know how much it could hold. Well, we'd need to get the area of one face of the cube, so that's 4 times 4, and then multiply that with the height of the cube. Because all the sides of the cube are the same length, we'd have 4 times 4 times 4. There are 3 4's multiplied together, so that's 4 to the power of 3. Let me repeat. To get the volume of a cube, you take one side of the cube and raise it to the 3rd power, you cube it. So 4 cubed is 64, which means the volume of our cube is 64 centimeters cubed. You can work out some simple exponential calculations using basic arithmetic. For example, you can work out 7 squared quite easily because that's just 7 times 7, and if you know your times tables, you would know that that's 49. But if you had a really complicated example, like 6 to the power of 6 or 29 squared, well, in the first example, that would be 6 times 6 times 6 times 6 times 6 times 6, which is not something you'd be expected to do even with pen and paper. You'd generally use your calculator for something like this. On a calculator, the symbol for raising a number to a power usually looks like this, or sometimes like this. If you open the Windows calculator and switch to the scientific view, the symbol is this. On my calculator, the symbol looks like this. So if I was going to do 6 to the power of 6, I would input 6 to the power of 6 equals 46,656. Some calculators, including my one, also have a shortcut for working out something squared or something cubed. So if I wanted to work out 29 squared, I could just put 29 squared equals 841. Or I could do 29 cubed if I wanted to know what that was, which is 24,389. Try working out some exponential calculations yourself. See if you can do some in your head and use your calculator to do the more complex calculations. In my next video, I'm going to be explaining exponential properties, which are like special rules or shortcuts that you can use when you're working with indices. So if you liked today's video or if you learned anything new, please do like and share my video. Otherwise, if you have a question or if you want to give me some feedback, feel free to put a comment down below and I'll make sure I'll try and get back to you. So thanks for watching, and I'll see you next time at Sneezy Teachers.